Hello and welcome to our next lesson on fractions. So we're going to recap where we're up to and then we're going to carry on. So before we've looked at the meaning of a fraction, we've looked at representing and identifying shaded fractions. We've worked on how to find a fraction of an amount. We can identify and find equivalent fractions, although some of you found that a little bit tricky. What we're going on to today is simplifying fractions and changing improper fractions to mixed numbers and vice versa. But if you don't know what that means just now, that is okay, because that's what we're going to learn in this lesson. And then next time we'll go on to some of these other things. Okay, so there's our two big jobs for today, are to learn to simplify fractions and change between improper fractions and mixed numbers. So first of all, we're going to recap what we've looked at previously. So first of all, shading. So when we're shading fractions, for example, if we've got 2/3, then what that means is our shape, whatever shape it is, excuse the rubbishy drawing here, our shape has to be split into 3 equal parts because the denominator, that's the number on the bottom of the fraction, tells you how many to split your shape into, and then the top number tells you how many to choose. So we choose 2 out of 3 blocks to shade. So 2/3 can be represented like that, or if we're sticking with pizzas, we can split our circle into thirds and shade 2 of them. Okay. Another thing that we looked at was finding a fraction of an amount. So let's stick with 2/3 and find 2/3 of £30. So if we're finding a fraction of an amount, it means we need to split our amount in the same way as we were splitting our shape here. Okay, so what we did here to shade 2/3 was we split our shape into 3 equal pieces and then we chose 2 of them. So to do that, as we're calculating a fraction of an amount, it means we need to take our amount and split it into 3 pieces and we need to choose 2 of them. In other words, what we're doing here is divide by the bottom then times by the top. Okay, so we're not using fancy maths language here, but remember the bottom is called the denominator and the top of the fraction is called the numerator. Okay, then we looked at equivalent fractions, and I know some of you found this a little bit tricky, so I will attempt to reassure you that it's not as difficult as you might think, but remember you can go over that again another time. We're just recapping at the moment. So equivalent fractions mean the same amount. So if we go back to our 2/3 here, let's just say I draw a line across the middle there. So what I've actually done is, without changing the amount that's been shaded, I have split that original rectangle. Instead of it being split into 3 equal pieces, it's now been split into 6 equal pieces. Okay, so the amount that's shaded in that picture was 2/3, and then by drawing a line, we made that 4/6. But we didn't change the amount that was shaded, all we did was draw a line. So it must be the case that 2/3 is the same size as 4/6. And the way that we create equivalent fractions is to multiply the top and the bottom by the same amount. In this case, they've been multiplied by 2. When we're finding a missing number in an equivalent fraction, let's say we've got 5/6 and that is something over 18, and we need to find the something. So we have to use this concept here, that to create equivalent fractions, both the top and the bottom have to be multiplied by the same amount. So we have to work out what amount that is, because we've already got one of the numbers, haven't we? We've got the 18. So we need to do 6 times what is 18. And if you think about your times tables, 6 times 3 is 18. So because we've multiplied the bottom by 3, we must multiply the top by 3 as well. So 5 times 3 is 15. And that's how we can find the missing number in an equivalent fraction. Now the thing that we're going on to next is simplifying fractions, because sometimes fractions are just more complicated than they need to be. Okay, and we're going to look at how to do that. Simplifying a fraction is usually making the numbers smaller, but sometimes at a higher level it can be to get rid of decimals that are within a fraction. Okay, but the kind that we're going to be looking at today are just where we need to make our numbers smaller so that the fraction is more simple to think about. Alright, so starting with 2/4, we need to find out a fraction that is the same size as 2/4 but is simpler than 2/4. So look, I'm shading 2/4 of that square there. But we can see, can't we, that the amount that's been shaded here is a half. And let's see what's happened to the top and bottom of 2/4 to change it into 1/2. So, what have we done to 4 to change it into 2? Well, we've either taken away 2 or we've divided by 2. I'm just going to write them down there. But remember, for these two fractions to be equal, we have to have done the same to the top and the bottom. So if we did 2 take away 2 on the top, that wouldn't give us 1. So it can't be take away 2. So thinking again, what's 2 divided by 2? Well, 2 divided by 2 is 1, isn't it? So we can see what's happened here is that the top and the bottom of the fraction have both been divided by 2 to make our numbers easier and smaller. So we're going to work through these other ones. Basically, all we're going to do each time is work out, I'm just going to write this here so we've got a bit more space. We're going to work out what we can divide the top and bottom by to get a simpler fraction. Okay, so we're going to divide. Oops. Now, when we're dividing, we've got to divide top and bottom by the same amount. So it has to be that these two numbers are both in the same times table, because we've got to divide by the same thing. So what times table will you find 5 and 20 in? Well, that would be the 5 times table, wouldn't it? So we're going to divide top and bottom by 5. So 5 divided by 5 is 1. And 20 divided by 5 is 4. So 5/20 is exactly the same size as 1/4. And I hope you'll agree that trying to imagine what 5/20 looks like is a lot more difficult than imagining what 1/4 looks like. Remember, we say 1/4 as 1/4, not 1/4. Okay, the next one. So 10/30. So again, we're going to divide top and bottom by the same amount. So we need to find a times table that 10 and 30 are both in. Now we've actually got a choice of a few here. We've got 1, 2, 5 and 10. So 10 and 30 are both in all of these times tables. But let's think about these. If we divide top and bottom by 1, nothing's going to change, is it? Because dividing by 1 and timesing by 1 is exactly the same. It doesn't change the number. So we know we don't need to bother with 1. We could divide by 2, and then we would have 5/15. If we divided by 5, we would have 2/6. and if we divided by 10, we would have the smallest numbers of all. So the thing to do is, if you've got a choice of numbers to divide by the biggest one you can, because then your numbers will become smaller. Okay, so we're going to divide by 10 on the top and bottom. So 10 divided by 10 is 1, and 30 divided by 10 is 3. But I want to show you what would have happened if we'd started by dividing by one of these other numbers. So let's start again with 10 over 30, and let's pick 5 this time. We're going to divide top and bottom by 5. So 10 divided by 5 is 2, and 30 divided by 5 is 6. Now, we have simplified 10 over 30 to get 2 6, because 2 and 6 are smaller numbers and easier to think about than 10 and 30. But it's not as simple as 1/3, is it? That's the simplest form of this fraction. This one, you can see the top and bottom are both in the 2 times table, so we could go again with that simplifying, and that would give us 2 divided by 2 is 1, and 6 divided by 2 is 3. So we end up with the same answer here as we had there, but this way took us 2 steps to get there, and this way took us only 1 step because we divided by the biggest number we could. Okay, so we're going to bear that in mind as we do the next one. So 12 over 16 is equal to, well, I'm just going to move it over a little bit. So what times table are 12 and 16 both in? In other words, what are the common factors of 12 and 16? Okay, have you heard that word before? Common factor. So the common factors of 12 and 16 are the times tables where you will find 12 and 16 as answers. Right? Our choices are, well, they're always going to be in the 1 times table, and we don't even need to think about that because it doesn't change anything. They're both in the 2 times table. 12's in the 3, but 16 isn't. They're both in the 4. 5, no, 6, well, 12 is, but 16 isn't. And we can keep going, but we're not going to find any bigger times tables than these. So remember, what we do is we divide top and bottom by the same amount, and we pick the bigger number to divide by. So we're going to divide by 4. So 12 divided by 4 is 3. 16 divided by 4 is 4. So our answer, when we fully simplified the fraction 12/16, is 3/4. And now we're going to finish off this sentence. To simplify a fraction, we, remember what we're doing? We divide top and bottom by the same amount. Okay, so we're going to do one more example, and that is 12 over 18. We're going to simplify that fraction. So if we think hard about what times tables we'll find 12 and 18 both in, we'll eventually come up with the fact that they're in the 1, the 2, the 3 and the 6 times tables. So to get to our answer quickly, we need to divide by the biggest of these numbers. So we're going to divide top and bottom by 6. So 12 divided by 6 is 2, and 18 divided by 6 is 3. So 12/18, when you fully simplify it, you get 2/3. Okay? Now when you're doing these by yourself, there are bits that you don't need to include. So if you were doing that as a question, you can just go straight to writing down the answer. You don't have to have the arrows on and what you're dividing by. If you find it helps you, then you should keep those bits of information, but you don't need them. That's, oops daisy, without crossing anything out, that's the information that you do need. Okay, so what I would like you to do now is pause the video and try these few questions. We'll make sure you're getting them right, and then we've got some more for you to do. So pause it just now. Right, now when we're ready to mark these, then I'll just quickly go through each one. So in the first one here, 15/40, we're going to divide top and bottom by 5, and that will give us 3/8. In the one across here, 8/20, we're going to divide top and bottom by 4, and that will give us 2/5. In the third one, 35/100, we're going to divide top and bottom by 5, which will give us 7/20. And then the last one, 21/30, are both in the 3 times table, so we're going to have 7/10. Okay, now, I'm showing you the answers there. Dearie me, don't need to do that. Right, so what I would like you to do now is pick a set of questions to simplify. So either pick the bronze questions, the silver questions, or the gold questions. For all of the questions, you've basically just got 3 things to do. You've got 2 fractions to simplify, and then you've got a question to answer. So 2 to simplify, and then a question to answer. So the questions for the bronze are the most straightforward, and the gold are most difficult, and silver somewhere in between. Okay, so if you pause the video just now, answer those questions, and then come back and check your answers. So the answers, if you're ready, or even if you're not, are here. So take a minute or 2, check those answers. If you're not sure, you can either watch the video again, or you can ask somebody else to help you with that, or you can jump back onto the call and speak to either me or your maths teacher if that isn't me. Okay? Well, the next thing that we're going to go on to is looking at fractions that are bigger than 1, and they're called mixed numbers. So, for example, we've got 1.5, 2 3/4, 4 2/5, 3 1/8. So that's how we say these. So we say the big number first, and then we say and then we say the fraction. So that's 1.5. Okay, 2 3/4, and so on. So we're going to have a think about what these look like. Okay, so 1.5 means 1 whole 1 and a half. So 1.5 looks like that. 2 3/4, let's go back. So we're going to have 2 whole ones. So 1, 2 whole ones, and 3/4. Remember, 3/4 means we split into 4 and choose 3 of them. So 2 3/4 looks like that. 4 2/5. I'm going to go back to circles. 1, 2, 3, 4. So we've got 1, 2, 3, 4, and 2/5. So split it into 5 equal bits and choose 2. So 4 2/5 looks like that. And then 3 1/8. Well, I'm going back to squares again because it's easiest. So 1, 2, 3 whole ones, and 1/8. So that means I need to split this final square into 8 pieces. I'm going to do it this way. And we need to choose 1 of them, 3 1/8. Okay, so they're fractions that are bigger than 1, but there's another way of writing down fractions that are bigger than 1, and that is to use improper fractions. Now, improper fractions have the numerator bigger than the denominator. In other words, the number on the top is bigger than the number on the bottom, and that's how we know we've got more than a whole one. So if we go back to our 1.5 up here, if I'd split each of those circles into 2, then we can count how many halves we've got all together, can't we? So we can say we've got 1, 2, 3 halves. And that's how we can write 1.5 as an improper fraction. We can write 1½ equals 3/2. Okay. If we look at 2 3/4, then if we split all of our squares into the quarters, then we can see how many quarters we've got all together. We've got 4 there, 4 there, and 3 there. So altogether we've got 4, 8, 11. So we've got 11 quarters altogether there. So notice from the last two examples that we had halves and we've got halves in the improper fraction too. When we look at the next one, 2 3/4, the number on the bottom of the fraction in the denominator hasn't changed. We're still looking at quarters. So that's something that we can look out for. The next one was 4 2/5. So if we split each of these circles, I'm actually going to do it in different colours so you can see it a bit easier. So if we split each of these into fifths, we can see that in each fully shaded circle, we've got 5/5. That makes sense, doesn't it? So we've got 5 there, 5 there, 5 there, 5 there, and 2 there. So altogether, we've got 4 lots of 5, so that's 20, and 2 makes 22/5 altogether. And again, look and see that the number on the bottom of the fraction there is exactly the same as the number on the bottom of the fraction there. So the denominator doesn't change. Again, let's look at 3 1/8. So if I split these squares all into 8, then we can see that we've got 8 there, 8 there, 8 there, and 1 there. So altogether we've got 3 8s. Look, we've got 3 lots of 8. So that makes 24. And another one makes 25/8. Okay, so the denominator hasn't changed. And look where we got the numerator from. Can you remember how we found that? We did our 3 lots of 8, and that gave us 24, and then we added the 1. So what I would like you to think about for a minute is, can you see how to change a mixed number into an improper fraction? If you've got no idea, just hang about and I'll tell you. But if you think you might be able to explain how you do that, then pause the video just now and tell somebody, whether that's somebody in class or somebody at home, or even if you're talking to yourself. Okay? So, the way to change a mixed number into an improper fraction is, we look at this whole number first. Okay? So, that's how many whole pizzas or whole chocolate bars we've got. And you imagine each one of those is split into 3 pieces. Okay, so if each one is split into 3 pieces and we've got 5 of them, that means we've got 5 times 3. Okay, so we've got 5 times 3, so we've got 15 thirds in our whole ones. And then we've got another 2. So 5 times 3 is 15, and another 2 makes 17. Alright, so the way to change a mixed number into an improper fraction is you multiply the denominator by the whole number, and then you add the numerator. So we do 3 times 5 is 15, add 2 makes 17, and the number on the bottom of the fraction doesn't change. Okay, so we're just going to write that down just now. So you multiply the denominator by the whole number, then add the numerator. Okay, so that's how you get the top of the fraction. And then the bottom of the fraction, does not change. Okay, so we're going to try that with these ones that we've got here. So if we look at the first one, 4 1/3. So multiply the denominator, so that's the bottom, by the whole number. So this is the whole number. So we're going to do 3 times 4. And I'm going to draw on this as we're doing it. So we're doing 3 times 4. And then we're going to add 1. And that goes on the top. And then the number on the bottom doesn't change. So 3 4s are 12. Add 1 is 13. So we've got 13 on the top. All right. The next one, we're going to do the same. We're going to multiply and then we're going to add. So 5 times 6 is 30. Add 3 is 33. So we get 33 on the top. And the number on the bottom doesn't change. It stays as a 5. Okay, and then the last one. Use different colours so we can see it more easily. We times and then we add. So we do 9 times 2 is 18. Add 7 makes 25. And then on the bottom, the number doesn't change. Okay, so this is our rule here. Multiply the denominator by the whole number, then add the numerator, and the bottom doesn't change. But when we've got, for example, our fraction like this as a mixed number, all we're doing is this times this, and then add that, and it goes on the top. Okay? So what I would like you to do is pause the video just now, and I would like you to change each of these mixed numbers into an improper fraction. So just choose which set of numbers you want to do, which set of questions. So again, bronze are the most straightforward, then silver, then gold, and the gold one has a quite tricky extension question for you to have a think about. Okay. So just remember the process. So if we're looking at this first question, you're going to do 2 times 2, add 1, put that on the top, and keep your 2 on the bottom. So pause the video then and answer one set of the questions. Right, so if you're ready to look at the answers, here they are. So take a minute, pause the video again, and check your answers. Check that you are correct for all of them. If you're not correct, if you've made any mistakes, see if you can work out why it's not correct. And if you can't work out why, then you could ask either somebody around you or pop back into the lesson and I'll help you, or your teacher if your teacher isn't me. Okay. Now, I had planned to do a little bit more with improper fractions and mixed numbers, but I'm actually going to leave it there rather than going on to the next bit because this lesson is long enough just now. So, well done on what you've achieved. And next time, I'll just show you what we've missed out. So next time, we're going to be looking at changing improper fractions to mixed numbers. What we did today was the other way round. We changed mixed numbers to improper fractions and we looked at simplifying fractions. Okay, so next lesson, changing improper fractions to mixed numbers, and then we're going to look at adding and subtracting. Okay, well done and see you later.